Okay, so where do degrees come from? So the concept of 360 degrees being equal to one circular rotation is thought to have originated from the Babylonian civilization, which used a base 60 mathematics system. So compared to our base 10 system today. So what do we mean by base 10 versus base 60? Well, base 10 means that as you count up, right, 1, 2, 3, 4, 5, 6, 7, 8, 9, and you hit 10, you increase to the next decimal place, the next decimal place up. So you can see the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9 occupy the first decimal place, right, with a zero out in front. And then as soon as you hit 9, which is the last digit before 10, then when you hit 10, you add a 1 to the tens place. Now, base 60 does the same thing, but instead of going from 1 to 9 and then jumping up to the next decimal place, with base 60, you go from 1 up to 59. And then 60, you jump up to the next decimal place. So you can see how, a 9 on base 10 is very much like 59 on base 60. And when you count one more on both, you jump up to the next decimal place, just like we did here. And, with base 60, you then count up to 59 again. And if you were to count one more, then you add 1 to the next decimal place up, which would go from 1 to 2. And now with 2 up here, you just start counting again, 1 to 59. Okay. And, that's similar to what we do, right? You go 1 to 9. The next count would be 10. So it jumps up. Then you go 11, 12, 13, 14, 15, 16, 17, 18, 19. And when you count one more, this 9 goes to a 0. And you increase the tens decimal place by 1. So now you go into 20s. But notice that in our base 10 mathematical system, we have zeros, right? We have a 0 as a placeholder. Let's see here. The Babylonian base 60 did not have 0 as a placeholder. Okay, they do not have 0 as a placeholder. All right, so, that seems awfully backwards, right? We're so used to the base 10 and it's so convenient in a lot of ways. Why was this base 60 system developed? Well, um, first of all, you can count from 1 to 12 using both hands. Okay. So if you look at, the human hand, so we have a thumb, and you got your thumb and 4 fingers. You could use your right hand, and kind of point to it. Something like that. Okay, you could use your index finger, and you could point to each of the 3 knuckles on each hand. So you could do 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So here's knuckle 1, and there's knuckle 12. So you could count 1 to 12 just by pointing with one finger to each of the knuckles on your hand. Okay. And then you could count from 13 to 24 by using the next finger on your hand. And then you could use the next finger on your right hand and count each knuckle. And so you could actually count from 1 to 60 using just your left and your right hand. So Babylonians, not having zero as a placeholder, they couldn't do decimals. And so to avoid decimals, you need a number which can be divided without producing a decimal. And so this was, kind of like a nice coincidence of human anatomy, um, in that you can count to 60, using both hands, and 60 has 12 divisors. So 12 numbers that will divide into 60 evenly. And so you can have 1 through 60. Those are your 12 dividers. And so, as example, you can have 60 divided by 2. That gives you 30. That's an integer without a decimal. You can divide 60 by 3 and you get 20. That's a whole number without a decimal. You can take 60 and divide it by 4 and you get 15. Again, a whole number without a decimal. So this gives you a lot of options to subdivide 60 into smaller parts without it getting complicated. So that's very convenient, especially if you don't have a calculator. If you just want to stand across from somebody and communicate some values, money, calculations on inventory, making trade deals, you could just do it with your hands. By contrast, if we use a system that has decimals, so if we had 10 divided by 2, okay, you get 5. Okay, that's a whole number without a decimal. But then if you take 10 and you divide it by 30, or sorry, by 3, you get 3.33333, and it goes on forever, right? Those threes just keep going. So this is a messy decimal, right? Because you could never get to the end of that 3. So having base 60 and all of these whole numbers that come out when you do division by these divisors are really advantageous. And so if you take an equilateral triangle and you make each equilateral triangle so that it has 60 divisions in each corner, and then you arrange 6 equilateral triangles in a circular pattern, you add up all the 60 divisions 6 times, because you've got 1, 2, 3, 4, 5, 6. You've got 6 60s as you go around. Well, that means one full rotation is 360 divisions, or 360 degrees. And 360 has 24 divisors. So there's 24 numbers that will divide 360 degrees without a remainder. So that is, believed to be historically accurate. That's the origination for why we have 360 degrees that divide one full rotation.